Our next set of trigonometric identities is called the half angle identities. And they're similar in idea to the double angle identities. With the double angle identities, I'm just going to scribble some notes here, we would say things like sine of 2a. What's that equal to in terms of just sine of a? And we got something like this, 2 sine a cosine a. Okay, and sometimes that's useful as a way of re-expressing trigonometry of big angles as smaller angles. Well, this time we're going to go in the opposite direction. I'm going to say, what's the sine of a small angle, like a over 2, expressed in terms of just the angle a? And don't worry, we're not going to get into never-ending identities here. This is kind of the end of the line for the popular ones. What we're going to do is use our power reducing identities to help us through this problem. And what I want to do is focus your attention on this guy right here. And can I actually, you know what I'm going to do? I'm going to copy this thing. I think this will work best this way. I'm going to copy this guy down here. We're going to work on this thing, and I'm just going to make an angle substitution. Okay, I'm going to substitute, we'll use purple here. Instead of phi, I'm going to use a different angle, and I'm going to call this angle, I don't know. Let's call this angle a over 2, okay, instead of phi. So that'll be a over 2 right there. And here's where I'm going to ask you something. What is 2 times a over 2? What is this thing right there, that 2 times a over 2? Well, you should be able to figure this one out. 2 times a over 2, the 2's cancel out, all you get is a. Okay, so now look what we have here. I'm just going to erase the contents here. Let's re-express this using that substitution idea. This becomes, this becomes sine squared of a over 2 equals 1 minus cosine a over 2, right? And if you look back and forth between this and the power reducing identity up here, you should be able to see the pattern, the similarity between the two. But the one on the bottom is a little more useful for what I need right now, which is producing the half angle identity. So let's take this one step further. Right now I have sine squared of a over 2 equals 1 minus cosine a over 2, and I want to just square root both sides. So what's that going to give me? It's going to give me this, sine of a over 2. And remember, this is really a plus or minus square root on both sides, which turns it into sine of a over 2 equals plus or minus the square root of 1 minus cosine a all over 2. That is your half angle identity for the sine of a over 2. And likewise, we're going to take these other equations here, cosine squared of phi, and this guy here, tangent squared of phi, to create half angle identities. And I'll spare you the derivation for each of these because it is very, very similar to exactly what we just did for sine. So I'll just write them here. We have cosine of a over 2 equals plus or minus the square root. And if you look at the half angle identity, what I'm writing right here should make sense. The square root of 1 plus cosine of a over 2. And our last one, the tangent function. We can either go back to the power reducing identities for help on this, or you could just look at sine and cosine for this half angle and come up with it yourself by doing the division. This is going to be another square root, plus or minus, but on top we're going to have 1 minus cosine a, that's from the sine function. On bottom, we're going to have 1 plus cosine of a, that's from the cosine function. And this forms our half angle identities. All right, so let me just clean this up a little bit. While I'm cleaning my workspace, I want to talk about that plus or minus sign. What exactly is going on there? What is the deal with that thing? All right, here we go. This guy. Give me some interesting magenta. What is the deal with that plus or minus sign? Well, it's up to you. It is your job to figure out whether a plus or a minus sign is appropriate. All the algebra has told us is that it's one or the other. But you, dear math student, have to figure out based on the standard coordinate plane, you have to figure out where your angle is. And for example, if you're in quadrant 2 over here, what would the sign of the angle be, positive or negative? You would pick a positive sign. And would the cosine be positive or negative? I hope you pick negative cosine right there, and negative tangent. Okay, so this is how you know the quadrant information is how you know whether you're a plus or a minus on that square root. Do not just take a 50-50 guess. It's not going to be a great strategy in the testing for this one.